There's just a few more things I want to share with you in our Intro to Probability section here, section 3.1. So let's say you toss a coin 100 times and record the number of heads you get in a frequency table. So we have 59 heads and 41 tails. So if I wanted to find the probability of heads using my frequency table, I would say the probability of heads is 59 out of 100, or 0.59. But you say, wait a minute, no, isn't the probability of heads 0.5? Don't we have an equally likely chance of getting a head or a tail? Both of those are true. One of these is called the empirical or experimental probability. This is the second method. We're getting this from data. So that's the empirical or experimental probability. And this is the theoretical or actual probability. Now, they're fairly close to one another, and you've been around the block a few times. You know that if you toss a coin 10 times, you're not going to always get exactly 5 heads and 5 tails. Matter of fact, you might get 2 heads and 8 tails. It could be very different. But you know that if you kept tossing it for a while, you should end up with pretty close to 50%. And maybe the more you toss it, the more close it would get, but you're not really sure. So let's take a look at a little coin toss app here. Okay, so let me pull this up so you can see what's going on with this. So what we have here is we have the probability of heads is 50% and number of tosses. I'm going to go down to 1 toss. So if I toss the coin, oh look, 100% heads. The blue represents the percentage of heads, 100%. If I toss it again, oh, now I'm 50-50. If I toss it again, oh, now I've got 2/3 heads, 2 out of 3. Toss it again, I've got 50-50. Oh, toss it again, now I've got 40% heads. Toss it again, ooh, only about 33% heads. Oh my gosh, less than 30% heads. Oh my word, 25% heads. I'm wondering, oh, what's going on here? So in my tosses that I've made, I have 6 out of 8 are tails, and I'm feeling kind of weird about this. Oh, now my line's coming up again. Okay, I'm going to keep tossing. Oh, I'm still at only less than 30% heads, and I'm going to just keep going. So this is really weird right now. If I show the true probability, I should be right up here at 50%. So what I'm going to do is I'm going to keep tossing. I am just going to toss and toss and toss this coin. And look what's happening as I'm tossing the coin more and more. At the first, I was just all over the place. But it's looking like it's not quite so all over the place. And it seems to be climbing a little closer to my expected 50%. So I'm going to toss a bunch now. So let's do 100 at a time. So let's do 100 tosses. Let's do another 100 tosses. It's still wiggling around a little bit, but look at this. It's not nearly as far off as what it was before. I've made 296 tosses now. So let me toss some more. It's kind of going down, isn't it? But the more I toss, the more I'm going to end up leveling off at the true percentage. You can see that my variability is not as much as it used to be. So I would imagine that if I kept using this app and tossed it maybe another couple thousand times, it's probably going to get pretty close to 50% heads and 50% tails, because it's just a totally random thing that it's doing right now. But that's the idea, is the empirical or experimental probability will not necessarily exactly match the actual or theoretical probability, but in the long run it should get pretty close. So this is what the law of large numbers said. It, as an experiment, is repeated a very large number of times. a very large number of times. The empirical probability, that's an I. Empirical probability approaches the theoretical probability. So let's talk about empirical again. Empirical means using data from an experiment. So I'm tossing, and when I talk about a probability experiment, like tossing the coin, you know, tossing a coin. And the theoretical is the probability, the actual probability using probability rules and theory. And maybe even a little bit of common sense. I know that the probability of heads is equal to 0.5. I just know if it's a fair coin, it should be equally likely to be heads or tails. Okay. Now, a few more things about probability. So I'm going to repeat law of large numbers because it's very important. As an experiment is repeated a very large number of times, the empirical or experimental probability approaches the theoretical or actual probability of an event. But they may not ever be exactly equal, because when you toss a coin, it's still not going to be exactly what you think. Okay, a few more things about probability. The probability of an event is always a number between 0 and 1. Or you can think of 0% and 100%. It's always going to be in between that. We can't say that the probability is more than 1, because 1 means it's going to happen. So if we say the probability of an event is 0, it means the event can't happen. There's no chance. If we say the probability of the event is equal to 1, that means the event always happens. There's no chance that it won't. But most of the time, it's in between. And as we said before, that probability can be written as a fraction, or as a decimal, or as a percent. That says written. I know that's really poorly written, but let me try that again. This is the word written. Probability can be written as a fraction, decimal, or percent. Now, another thing I wanted to define is what's called the complement of an event. It's just the opposite of an event. So the probability that event E happens is equal to 1, or let's say the complement of an event. All right. So the probability of, well, I'll do it like it is in my written notes. The probability of event is 1 minus the probability of the complement of an event, or 1 which is the same thing as 1 minus the probability of not E. And you know, I'd actually like to go back and write that the other way around, because I'm defining what the complement of an event is. So the complement of an event looks like this. So the probability of the complement of an event, and usually use a little prime mark or sometimes a little c, is equal to 1 minus the probability of an event E. And this just means probability of E complement, the probability of E complement means not E. In other words, not this happening. So let's look at an example. So for example, let's say the probability of rolling a 5 is 1 out of 6. So the probability of the complement of that would be the probability of not rolling a 5, What's the probability of not rolling a 5? Well, it's going to be 1 minus 1/6, which is 5/6. So we say these events are complementary to each other, rolling a 5 and not rolling a 5. Their probabilities will always add up to 1. So the probability an event and its complement always add up to 1. So in this case, the event was 1/6, the complement was 5/6, that adds up to 1. So that's an important thing to know just about what the probability of a complement of an event is. Now, let's take a look at odds versus probability. So the odds that someone's birthday falls on a weekend are 2 to 5. That doesn't mean there's a 2/5 chance that their birthday falls on a weekend. It means there's a 2 out of 7 chance. So the 2 is the number of outcomes for birthday on the weekend. And 5 is the number of outcomes for birthday not on the weekend. So basically those two things are complements of each other. So if we say probability of birthday on the weekend, that would be actually 2 out of 7. So we have to add those two together to get the total outcomes. 2 and 5 would be the total number of outcomes. And probability of not on the weekend equals 5 out of 7. So that's how odds work. The odds that someone's birthday falls on the weekend are 2 to 5. Now sometimes, usually when we say that the odds of something happening, we put the number that it could happen on the first number and the number that it doesn't happen on the second. But for some reason, when you're talking about odds for a winning-losing situation, often they're expressed in the opposite order. So the odds that Duke will win the NCAA championship are 8 to 1. That means that he's not going. That doesn't mean that we would expect them to win 8 times more than they would not win. Basically, the probability that the Duke would win would be 1 out of 9 possibilities. There's 8 possibilities. 8 times they would not win. 1 time they would win. So this is the probability of Duke wins is equal to 1 out of 9. That's the actual probability for those odds. Now another thing that you might hear sometime is there's even odds. There's even odds on that. Even odds means the odds are 1 to 1, or there's a 50-50 chance. In other words, that the chance for and against something are even. The chances either way for and against, win or lose, are the same. So that's what even odds mean. So I just wanted to show you the difference between odds and probability. So basically when you're dealing with odds, the number on one side of the colon tells you how many ways something can happen, and on the other side how many ways it cannot happen. And so you have to add the two together to get the total number of outcomes, and then the two would be complements of each other. So the probability Duke wins is 1/9. The probability that Duke loses then would be 8/9. Not D. P that Duke loses equals 8/9. So there's just a little bit more about probability for you.